start recording. Okay, let me have some. So I understand that you would like me to talk about binary trees, right?
Yes, yeah.
So actually, the point here is that linked list is somehow tied to binary trees, and it's like a slight introduction to binary trees. So are you fine with linked list, or you would like me to go through it first before we go through binary tree?
I understand linked list, but is there any coding in it? Like any program?
So the problem with linked list with you is in the coding. Did I get you right, or how?
Yes, could we just revise through that? Because I don't really remember it.
Okay, so no problem. So let me just go slightly over class 3 exercise. I was trying to get you more exam questions in both linked list and binary tree, so that you know what kind of question that you should expect in these two. Okay, so that's why I didn't have more chance to look at your previous exercise, which is the class 4 exercise. But for class C, I have some remarks. So let me just go through it fast, and then we can continue with the linked list and binary tree. Okay?
Okay.
So, okay. So for class 3, for question 3, so we talk about there is 2 or more records that was hashing and how to avoid the collusion. So we said 2 or more records could have the same hash values that result in a collusion. Explain how the hashing algorithm can be designed to handle collusions. So let me see. Yeah. So the correct answer actually can be one of these 3. So we can check each location serially until finds a free record. This is a linear search. Or we use an overflow table that stores the record with collusions. So that's the common thing that we always use. And then this is an overflow table. And then or implement a linked list for each hash location. Okay. And then we store a record in the first free node in a linked list, and then update the location last node linked list pointer. So it means that we have a location like that, and then we have linked lists keep coming out from it, and then we keep updating the pointer. So that will carry all the values that have collusion with this specific place. But again, let us see first how the linked list looks like, and then maybe we'll understand this. So this is what we implemented with code previously, okay? And this is the extra 2. So that was, yeah. And that's basically what should be the answer.
Sorry, continue.
Sorry again. Did you hear me?
Okay. Yes.
Should I continue?
Yes, yes.
Okay. So, okay. There was a question that say, get the customer, the function get customer. It takes a customer ID as a parameter, and it passes the customer ID to the function get record location, which returns the calculated hash value. Read and returns the record from the hashed location in the file. This is a file. So your basically your answer. Let me see here if I really put your answer. No, unfortunately, I didn't put your answer. But yeah, your answer is here actually. So your answer for this question, this is what you put here. But actually, the correct way to answer that kind of question, again, this is a question. So you get a customer, okay, and this get customer takes again. Sorry.
I just said yes.
Okay, so the get customer ID as a parameter. So as you can see here, so we have to provide a parameter customer ID for the get customer. Okay, and then we are reading this binary file, and then this is the operation related to reading the binary file. we open the file, we seek the location, and we get record, and then we close the file, and then we return back the customer record. So customer record, actually, we have been filling it in while reading that file or the binary file, and this get location actually get the customer ID and then get a hash value based on that. And of course, I understand that maybe at that time we didn't really go through the how to get the location and how to get the place inside the binary file.
Yeah.
Okay.
So what's the use of seek?
So seek, actually, it is seeking the exact record using hash. So okay. So again, we use hash. So okay, imagine this is exactly similar to the array concept. So if you want to read a specific record, okay, so customer record is a record type that have a record ID, and in this case is called customer ID. So this customer ID, so let's say there is a number of customer IDs here for every record. For every record, we have a customer ID, and we want to, for example, to read this specific record ID or customer ID. We don't need to read one by one to be able to read that specific record that is related to the given customer ID. So we have to calculate the exact location, get the record location based on the hashing algorithm that is used. So we have to ask him to search for the place that we need to go directly and read from. Okay, so the file, that file or the binary file have a number of records like that, similar to the array concept. Okay, so we don't need to go one by one to read it. We want to know the exact place to read from, and that is done by the get record location. So it will tell me exactly where to search inside the binary file. And then after we know where exactly we should get the record, and then we should close the file and then return back the customer record. Does this make sense?
Yes.
Okay, good. So let me see here. So typically, most of the questions that come so far, I never saw in a previous exams anything that come for reading that files specifically or binary files, especially the one that using hash in the searching, other than the one that come in pseudocode. So mostly it will come in pseudocode. So if you know how it looks like a function like that, and I believe in our class when we explain this binary search, we also explain about seek. Okay, so if you know how it looks like that, then I believe you should have no problem settling all the questions related to the binary files that use hash. Okay, so okay, now let's go forward here. This is a question that, so here, actually, he have a question. A program allow guests to input a meal option at a wedding. Guests can choose the meal option 1 or meal option 2. The program will keep counting the number of each meal option chosen. So he provide us with a pseudocode. The program ends with a value other than 1 or 2. So if we enter other than 1 or 2, the program will end, and then it will output the count of each meal. So we ask it here, you, to actually, let me see if we already, let me see. Yeah. Actually, here is what here is the code, if I'm not mistaken. And here is the most important part of the code, which is the while. And that actually was your answer here. So he asked us actually to change the while loop that he's using and use recursive call. So this recursive call, actually, you do it somehow partially correct. So you said meal count, you call the meal count function here, which is okay, fine. You call it in the correct place, but you call it without parameters. That's the only.
Okay.
Yes. So
yes.
you just need to call it with the parameters, because you cannot call a function without the necessary parameters, right? So that's it. I mean,
Yes.
Other than that, you answered correctly. Okay.
Okay. Yes.
Okay. Good. So so the correct one, like I said, you just need to call it with a option, with the parameters, and that's it. And let me see. Okay. So yeah, this is to be discussed next time. So now we go back to linked list here. This is page, let me see here. Sorry, linked list. Okay, so okay. Do you know, first, let me discuss with you so that also you can use. So we have 2 pointers in the linked list. Do you know what is the purpose of having these 2 pointers?
The start pointer and the free list pointer. Yes. The start pointer is where the linked list starts, and the free list pointer is for the empty nodes, so we can store empty nodes.
Okay, and why do you think they come up with a so complicated data structure?
It's easier to store and delete data from these nodes than from stacks or queues.
Perfect answer. Yes, this is a perfect answer. So somehow, yes, you have a good understanding of what's happening here. So I would say, so you already know how this kind of format works, right? So you know how we can add to the list and how we can delete, right? So because many questions will come also about adding and deleting and even filling in a table like that. So let me go through since you know the basics here, let me go through this. So sometimes, I mean, he take us one step forward, that he tried to use only the start pointer, and then he start to add a way that we can use actually 2 kind of pointers. So start pointer and the free list pointer. So I would like to ask you here, so when we initialize, so consider this is like a 2 arrays, one having the data and one having the pointer. So if I ask you here, the first time when we initialize the pointer array, how should we initialize it? So should we initialize it to be linked together? Or so do you understand why is it pointing like that? Do you understand what's the meaning?
Yes.
Okay. So, and
pointing to the next index?
Yes, exactly. So here is pointing to the start, and from this is pointing to the next, and so on. Yes. And you already know that we have to end up with -1, right? At the end of the list, right?
Yes.
Okay, perfect. And then we move to the next. So let me now check with you. So if we want to add an element, I believe, so can you describe to me what you see here from the start pointer and the free list pointer?
The start pointer shows 1, so it would start at index 1 with data B.
Okay.
And then it points to 2, index number 2, so data D.
Okay.
And then it points to index 0, which is L.
Okay.
And then it points to -1, which is the end of
Okay,
the
perfect.
list.
Perfect. And 3 points to our heap or our empty list, right?
Yes.
Perfect.
Yes.
Perfect. Perfect. Okay. And if do you understand? Because again, if you want to look at the code of adding, yeah, is slightly complicated. It have some details inside, but if we don't know the concept very well, then it is very hard for us to understand. Of course, when we are talking it like that, it's very easy. But if we want to put it in a code and then we want to add or delete, that would be troublesome. So I would like to understand from you now, if we want to delete something from here. So if we want to delete the D, which is almost the second element in the linked list. So can you tell me how did we delete that and what is the process here that we've done? So now we are starting with 1, right? So now I'm listening to you.
Yes. Wait, I'll just see it once. So we're deleting the, okay. So first we go to the index of the, we delete the data, and then we move the index to the next pointer.
So now D is pointing to 3, right?
Yes.
So
we delete D, and instead of B, the previous pointer pointing to 2, it will point to 3.
okay. So no, first let's talk about the
Okay.
yeah.
No, wait.
So now first
it will point to the, yeah.
I want to ask you first.
Okay.
Can you check before we delete how it should look like first before we start to adjust? So first, how it is arranged. So which element come first? B, right?
B.
Okay.
Yes.
After B.
L.
No. Before we delete, we should supposed to be.
Oh, it's going to D.
Yes, and then after D, it is 3. And most of the time, to reduce the complications in the current course, they talking about ordered linked list. So if you look at the order here, typically B come first, after this D, and L comes the last, right? So always put it, so even if you put numbers, it will be always like that. It will be always ordered. So if you confuse a bit, if it is long and it's confusing to you, so put it in this way. Typically, he will not put L first, okay? Because this is supposed to be, most of the time he's teaching us in this kind of A-level course, it is an order. So ordered, yeah, PDL, right? This is the order of the alphabets, right?
Yes.
Okay, perfect. So now, free list used to start as 3, right?
Yes.
So, okay, when we delete something, what we want to do? Two things. We need to do 2 things. First, we need to do some adjustment on the free list, and we need to also do some adjustment on our ordered list that is pointed by the start pointer. So 2 things we need to do. So first, tell me what we need to do towards the free list. So
yes, we changed it points to index number 2 instead of 3.
So this means that we add D, the deleted item, to our free list, right?
Yes.
Okay, and then the pointer of D should be pointing to what? So can you see here? So previously we start the free list here, right? And then we added D, and then it means that we need to change the pointer of D, the deleted item, from pointing to the normal ordered list to point to the next item, to
the empty
previous start of the free list. So we take here 3,
okay.
we put it here. Does this make sense?
Yes.
Perfect. Okay, so now tell me what kind of adjustment we need to do on the 2 items. So previously we had 3 items, we deleted 1, we have 2. We start with 1. So how is the changes now?
The pointer pointing to D, which should be moved to the next, basically the index 1, it's originally pointing to 2. We should instead point it to 0.
Okay, so it should point, instead of D pointing to here, to L, we should make B. Yes, okay, perfect. Okay, it's good. Okay, so so first we have, we have many choices actually how he can implement this linked list. Sometimes he used 2 arrays, similar to what is shown here. And then, of course, he have to always use 2 pointers. That is clear all the time. And then sometimes he will come to tell us that he create array of records like that. So he will create a node, a structure called node sometimes, and this node will have 2 parts. Have you seen something similar to this before? So it will contain data part and pointer part. Did you see a structure in Visual Basic before?
Yes.
Okay, so here in this condition also it is possible that he use an 2D arrays. The first part of the 2D array that he used for the data, the second part he will use for the pointer. So it should not confuse you somehow. We know that we need to store two information for every node that we have. One for data and one for the next pointer. And this is always the same, it never change. So let us have a look next here. So in pseudocode, so again, he defined the list node like that. One should carry the data, like we said, the other one should carry the pointer. And in Visual Basic VP, then he used a structure node, and also the same concept like here, data and data as an integer, or even can be as a string. It depends on the data he want to insert. Next node and pointer is pointing, it's the same concept, it's just a different naming. Is that clear? Okay, so now let's have a look. Do you know how we initialize this nodes or linked list here?
Yes.
Okay, perfect. Then I would like you to, if you know this very well, then I believe reading the code here will not be an issue to you. So can you please try to read the code here and tell me what do you understand?
Okay. So first we're initializing a variable called null pointer to -1. It would tell us when the list ends, and then we are declaring the start list. Yeah, and we're initializing it to null pointer. Yeah.
Yes. Okay. Perfect. Yes.
Because there's no data in the list.
Perfect.
And next we are initializing the empty list pointer to the start of the list, which is the index 0.
Okay.
and then there's 9 nodes in the linked list. And oh yes.
So here you understand that this is a 1D array, right?
Yes.
Okay, it should carry how many elements?
Nodes.
But it's
10.
as a node. Again, sorry. 10 nodes. Okay,
10.
Perfect. Yes, exactly. From 0 to 9. Yes. Okay, what about this loop? What is this loop doing?
Why is it the length dot length -2?
Okay, so if you look here, so that is exactly what is happening here. If you look here, he defines the array. It's an array. It's a list of list node, right? List node is our node, right? And then he didn't loop here from 0 to 6. He looped from 0 to 5, right? And then on the 6, he assigns a null pointer because again he is trying to link the link. He trying to initialize it to the proper format where every record point to the next. So we know here every record should point to the next. Every record should point to next, except when we reach here, this is -1. So there is nothing to link to, right? So yes, exactly. So that is how we do it in coding. It is if you look here at the pseudocode, it's a similar concept here, except that slightly, because here. So what should be the length? It should be 9, right?
10.
And the length is 10. Yes. Perfect. Yes, perfect. And then instead of putting -1, we should put -2 because the last one here should be, since we are having 10, okay, and the length give us 10, and then we -1, so it means here we are assigning to the 9th. So we should close now, and should we open again? You know, right?
Okay. Yes.